Hi students, today let us see nanomaterials classification. So it is classified as 0D, 1D, 2D and 3Ds. So 0 dimensional, 1 dimensional, 2 dimensional and 3 dimensional. So what is 0? It is confined in all direction. There is no movement in x-axis, y-axis, z-axis. It is confined to one single unit in all the direction, right? One dimensional, you can see the figures down so that you can have a clarity on it. One dimensional, any rods or fibers which are in that form, we call it as one dimensional. Okay, then two dimensional is x-axis, y-axis, sheet like arrangements. Okay, and three dimensional is you can have the movement in all the three axes, x-axis, y-axis, z-axis, right? So that is three dimensional. Let us see the definition. All dimensions at nanoscale, length, breadth, height are confined at a single point. We call it as zero dimensional. Okay, so here there is no movement at all for electrons. Okay, then one dimensional nanomaterials have two external dimension at nanoscale. So y-axis, z-axis, say at nanoscale means it is confined to what I can say, it is confined to one unit and only one axis, either x, y, z. Either of the one axis is extending to a greater length, which is in micro scale and which can be extended is a one dimensional nanomaterial. Two dimensional nanomaterial, here one axis is confined to nanoscale and other two axes are in micro scale. So we have in the form of sheet like thing. So either of the two is in the form of having a macro scales. Okay, micro or macro scales. Three dimensional displays in no nanoscale. Okay, displays internal scale feature but no external dimension at the nanoscale. It has all parameters, length, breadth and height. Okay, so example, spheres, clusters for 0 dimension. For 1 dimension it is nanofibers, nanotubes, nanowires, nanorods, etc. And for 2 dimensional it is thin films, nano coatings, nanoplates, etc. 3 dimensional it is nano composites, nano structured material, etc. So what is the property which makes it different from all the 3 dimensions, right? In 0 dimension it has poor electrical conductivity. There is no movement of electron in either of the axes because all the axes are confined. It is confined to one particular point, so there is no movement of electron at all. So it is a poor conductor or bad conductor. But it possesses a very high surface area. Since it is a smaller particle, so larger surface area are exposed, so it has a high surface area property, so it can exhibit a high catalytic property. Okay, under one dimension conductions is possible with defects. If we have defective nanofiber, nanorods, nanotubes and all, they are conductive in nature. In two dimension conduction again is possible with defects. Okay, with perfect structure there will not be any conduction. With defective structure we can have conduction. So here in one dimension conduction can be in the one axis. Electron can move in one axis, not in all the axis, either of the one axis, but in two dimension can move in two axis. But defect is very important. If defect is there, conduction is more. Okay, three dimension conduction will be there, full conduction will be there, all the three axes, electron is free to move, it has a lot of room to move, right? But surface area in turn turns out to be lower. Okay, as we start from 0 dimension to 3 dimension, surface area decreases, conduction increases. Thank you students.